start with, we are going to be having a look at these funny little three-legged components over here. What is this? This is a transistor, and this is a semiconductor-based component. It uses a silicon base, and this was the most important invention in electronics, or arguably the most important invention overall, that happened in the 20th century and is the foundation of all digital electronics and computers. Every computer device is making decisions using thousands and thousands, or if not millions, of transistors. And there's a whole bunch of different types of resistors, and really it can get very confusing over all of the different types of transistors that we've got. But really, the transistor that we've got here is a very small transistor. It's not a high power transistor. This one over here, you can see, is a lot bigger and a lot heavier. It's made out of metal so that it can sink heat. This is a high power transistor, or what they call a Mosfet transistor. And so there's a bunch of different types, and each one has their own unique application. The transistors that you're using in you'll have in your computer don't look like this. They are too small to actually see. But what we've got here is the basic principle of what a transistor is, and we'll go through, I think, some demos on transistors at a later stage. But really, the transistor acts as a electronic switch that we can use to amplify signals and circuits. And so instead of having to turn a switch on with your finger, you can send an electrical signal to the middle pin of the middle leg of this transistor, and then it turns on and allows the legs from on the either end to turn on and let electricity pass through them. That's a very quick summary of what a transistor is. Next we have what we call diodes, and diodes are similar to transistors because they are also silicon-based semiconductors. And if I can get one out of the box, there are a whole bunch of different types of diodes as well, but the core principle of a diode is that it's a semiconductor-based component that allows current to only flow in one direction. So it's a polarized component. Electricity cannot flow from negative to positive in a diode on conventional current. And so we can use this to control the direction of electricity, and this is what we call a rectifying diode. It can take 1 amp of current, and this is one of the core components that we use for converting alternating current into direct current. But really it's just a one-way valve for electricity, and there's a whole bunch of different types. You can see this one is way smaller, this one is way bigger. This will take several amps of current going through it. It gets really hot, and that's why it's made out of big, and it's got this screw on it so that you can screw it onto a big heavy block of metal or something so that it can dissipate that heat. You can also see this is quite a cool diode. The principle of this is that when the voltage gets to a certain point, it starts conducting electricity, and it's used in protection circuits. I can't remember exactly what it's called right now. The name slips me. We also have different packages of diodes, and so if you have a look over here, these are surface mount rectifier diodes. So these ones don't have the wires that the other ones that we've had a look at so far have. This one just gets soldered straight onto a circuit board and takes up much less space. So that is also a rectifier diode, but it is in a surface mount package. So those are diodes, and a diode is a semiconductor-based component that allows current to flow in one direction only.